Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you. In our previous video, we endeavored or we played around with the LandSat data sets, i.e. LandSat 5, 7, 8, and 9, and we generated a time series of the spectral signature of 3 selected features. And the purpose of that exercise is to try to get an understanding of the spectral signature of, let's say, a green area or an urban area or bare soil, so that we can distinguish using the LandSat data sets between features using the spectral signature. Okay, so we specifically focused on the LandSat data sets because it spans quite an extensive period, starting from the middle 1980s, going up to present. So we've got quite a lot of time to work with in terms of its daytime images of the planet, the surface of the planet. But it may not, so although that's the major advantage of LandSat, but the images is not very clear, meaning its resolution is not that good, which makes classification or interpretation a little bit more tricky. So for that, we could potentially use Sentinel. Now, Sentinel is similar to LandSat, but I think the resolution is much better, meaning the images are much clearer. It's better, it's more effective, but unfortunately, you don't have a lot of time in the data set. So LandSat is very good, long time, but the images are not that good. Whereas LandSat, the images I think is better, but you only have a smaller time window of images, and so this video will predominantly focus on comparing LandSat and Sentinel images. Okay, so for this video we go to our trusted Earth Engine, we go to platform. Before we go to the code editor, let's quickly explore the LandSat and the Sentinel data sets as per the landing page. So for do that, we go to data sets. And on data sets, you'll see there's this ribbon. You'll see there's the LandSat landing page, and there's the Sentinel. By the way, you can use MODIS as well, but for this tutorial video, we're only going to focus at LandSat and Sentinel. Okay, so you left click on LandSat, left click on Sentinel. I've already done it. You then go to the LandSat landing page. This should look familiar to you. We've done it in a previous tutorial. We've got LandSat 1 to 5, LandSat 4, LandSat 5, 7, 8, and 9. As I said, I prefer to work from LandSat 5 onwards, not from LandSat 4 or LandSat 5, because the coverage is not that good. So we'll start with LandSat 5, LandSat 7. Remember, they are very similar in terms of its bands, etc. And then you've got this quite a big jump from the 7 to the 8, and then 8 and 9 again is very similar. Okay, so you'll see there's overlaps, but as I said in many of the previous, when you look at them collectively, please take into account that there's overlaps and try to minimize the overlaps, because you know what's the point if they overlap? The images will be exactly the same. Anyway, so let's then go to LandSat 9, because okay, so there's Sentinel. There's this landing page for Sentinel, and there's specifically the Sentinel 2 that we're going to work with. That's the one that produces higher resolution multispectral images of the Earth's surface. These others represent other features. Okay, so this is the one that we're going to focus on. You'll see the data availability is 2015, but In many cases, the data is only available from 2017, depending on your region of interest. Okay, so let's then compare the LandSat 9 um, data set or instrument and the Sentinel-2 instrument. Let's compare those two instruments to see how they differ or how they are similar. Okay, so in each case, we're going to go to surface reflectance for LandSat. For Sentinel, we also go to surface reflectances. Therefore, they're still exactly the same. Okay, so here it says that it's LandSat 9, and it's level 2. It is Sentinel also level 2. Okay, so it's a multispectral instrument, meaning there's more than one band. And this is what this collection tour 2 tier 1 stands for. It's also multi-bands. Okay, so that's just a fancy word for saying there's more than one band. You'll see there's 2017. As I said, many of the places only have availability from 2017, whereas LandSat 9 is 21. But remember, LandSat 9 is just a continuation of 8. So, and 8 starts, I think, in 2012. So basically, you can basically make the argument this is data availability from 2012. This is from 27. Data is the European Union. This is the US. Okay, there's the so they've different continents, but they have the same purpose, and that's to collect daytime images of the Earth. And it works on the energy that is reflected and absorbed by objects on the surface of the Earth. Anyway, so let's have a look at the bands, or we can go to description. Let's have a look at description. I think it will be basically saying the same things. Okay, there's not much different in the description. As I said, they're basically collecting daytime images of the this Earth's surface. Okay, so let's go to the big one, which is the bands. Okay, the bands. Okay, so here you can see the first difference is the resolution. The LandSat, they're all the bands are in 30-meter resolution. Okay, whereas Sentinel, the bands have different resolutions, from 60-meter resolutions to a 10-meter resolution. But most of the usable bands, meaning the bands that we're going to use is, let's say, in classification, most of them are 10 and 20 meters resolution. You'll see there, band 2, 3, and 4. Remember, it's a blue, green, red. These are true color bands. They're in 10-meter resolution, whereas LandSat is in 30-meter resolution. And you'll see the difference when it comes to displaying those images. And we'll get back to that. Okay, so that's the first difference, is the resolution. The resolution is much smaller in the for the true colors anyway. It's much smaller in the Sentinel than in the LandSat. Okay, you'll see the band. Let's say B1. Band B1 is aerosols. Band B1 is also coastal aerosols. So that's no difference between the two. LandSat B2 is blue, B3 is green, and B4 is red. Let's have a look. In Sentinel, B2 is blue, B3 is red, and B4 is green. So it's exactly the same. The scale and the scale. Okay, this should be up to, so it should choose 0.00002. Okay, the subscale is 0.001. So not too much of a difference. Slight difference, but nothing too much. In fact, when we offset it, it most probably will get very similar to the scale. Okay, so from the scales, it's not too much. Let's have a look at the wavelength for B1. The wavelength in terms of its recording those transmitted energy that's reflected from the surf. It's 496 nanometers. Let's have a look and see. And band 2 is 0.4. Yeah, so it's very, very different, very, very similar. Yeah, not too different. Let's say the green 0.5, yeah, so converted with 0.5 as well, 0.56. This is 0.53. So the wavelengths are very, very similar. Okay, so at this stage, the only real difference is the resolution. the band names, the scales, and the wavelengths between LandSat and Sentinel are almost exactly the same. Let's have a look. They have then additional bands, which obviously is not available in LandSat 4. So LandSat has um, band 5 is red edge 1, band 6, band 7. So near infrared is only band 8, whereas in LandSat near infrared is band 5. Okay, so you'll see that the Sentinel, okay, has much more bands, many more bands than LandSat. And so it's the true color bands, the first 4 is exactly the same, but it's a latter number of bands that are different. Although they still have the same bands, just Sentinel has more bands. You see there's shortwave infrared 1, shortwave infrared 2 is band 11 and 12, and in LandSat it's band 6 and 7. Okay, so there's more bands in Sentinel, okay, much more bands in Sentinel than in LandSat, but and the resolution is different. But that's basically the only difference. In terms of the way they operate, collect images, use of the energy in terms of the different wavelengths, they're exactly the same. Nothing too different from it. Okay, and then as usual, there is the code. If you go to each landing page, at the bottom you'll see the code. Okay, you'll see the code, which give you a perfect starting place to work with Code Editor. Okay, so that just gives you a difference between the LandSat series and the Sentinel series. Okay, so how do they look? Okay, how do they look? So in terms of, so then we go to the code editor. Remember, I go to scripts and I start scripting and I save. And so I use the script column for my save project or my save script. Click on it and voila, there's my script. Okay, so there is, okay, my region of interest. As I said, I've made my region of interest a bit smaller given the delay in the images loading. So I've made it much smaller, so it's much more easy to digest and saves on the script itself in memory. Okay, so my clipping tool, then I've got my scaling factor for LandSat 8 and 9. So I'm only obviously going to compare LandSat 8 and 9 with Sentinel. No point looking at LandSat 7 or LandSat 5 because Sentinel wasn't available. Okay, so there's my scaling factor for LandSat 8 and 9. There is my LandSat 8 image collection, which I clip. And then there's my time frame. So I'm starting from 2019, not from the initial period, simply because Sentinel is not available before that, so there's no point. So I've narrowed my LandSat 8 time period to cover 2019. And then I've included a cloud filter, okay, which is always advisable. And that basically just means give me all those images in the collection which have a cloud cover of less than 5%. Now, if you find there's no images, then just change that number, make it a bit bigger. So hopefully that will bring images into play for your region of interest. Then I apply my scaling factors, and then with whatever amount of images there are in a collection that meets this criteria, I generate a median image. Okay, so now I'm going to have a LandSat 8 image, which is a medium image of all the LandSat images within this period that have a cloud cover of less than 5%, and it's clipped to my region of interest. Okay, and again, I've used that date. You'll see now why I've used this date. And I've also, if you look at LandSat 9, I have no overlap. So I've got 2 distinct periods of images. Okay, so for LandSat 9, same argument. There's my unique identifier, my collection, my time period that I've put there, also cloud cover. I've scaled it. Remember, LandSat 8 and 9 has got the same scaling factors. And then I generate a median image. So this variable, LandSat 9, is a median image of all the images within the LandSat 9 collection that satisfy the criteria of being in that period, having less than 5% cover, and is mapped to, clipped to my region of interest. Okay, and I'm displaying my LandSat images using this visualization parameters. Minimum, maximum, and the bands is the true color bands. Remember, it's red, blue, and green. Remember, that's the presentation that you and I see. That's the image that you and I see with our naked eyes. Okay, so this is what we've done previously. Nothing to it. All I've changed is the date so that I have distinct images, no overlaps. Okay, so then I do the Sentinel. Now remember, Sentinel, you have to first indicate a code which basically minimizes clouds. So this part of the code here, this part is to create a mask for the clouds. So that basically is a code that removes images that have clouds or clouds from images. Okay, and that's standard. Initially, that's the code also were relevant to LandSat. Okay, that images were also relevant to LandSat, but now we basically just use this code to say images so it's got a built-in program system. Okay, here we program it to delete clouds. Okay, so any clouds will be deleted, and that's what this code is all about. Okay, then we have our Sentinel, and you see it's the same Sentinel data set. I just create two different images, which is Sentinel-1 image, which is for 2019, and a Sentinel-2 image, which is for 2023, meaning the same periods as for the LandSat. And that's why I've used my LandSat 8 starting at 2019, because my first image for my region of interest in Sentinel is also only from 2019. So although the database, if I take you back, the database indicates that images are available for 2017, okay, but for my region of interest, it's only available from 2019, so a very short period of time. Okay, so that's why I have created a LandSat image for 2019 and another other period, because now I can compare it with the Sentinel image. Same thing, I clip my data range. I've got a filter. I've made it 20 because I am already deleting all or compensating for clouds there. And I add that, remember this map.master clouds is where I now include the mask, this one here that I've created, which is taking clouds out. That's what this code is about. It is referring to this part or this script, which basically says, give me no clouds or compensate for clouds. And then same as previously, I create a median image. And I call it Sentinel-1 image. So my Sentinel-1 image corresponds to my LandSat 8 image. Same images. Exactly the same, just different satellites. Okay, then my Sentinel-2 is for 2023. And you'll see it's exactly the same data as for my LandSat 9. So my Sentinel-2 corresponds to my LandSat 9, and my Sentinel-1 corresponds to my LandSat 8. Okay, so there's my visualization, exactly the same, except it's also true colors, just the band names are a little bit different, whether this is reference SR, this is this reference 4, but you see it's 432, and in this case also 432, which is red, green, and blue. So I'm presented. And then I'm basically going to present those 4 images. Okay, and there they sit within my layers. There's LandSat 8, which corresponds to Sentinel-1. There's LandSat 9, which corresponds to Sentinel-2. Now remember, you can do the change in visualization parameters using this little nut here, which gives you this block here, where you can play around with the stretching and all these things. We're not going to do that now. We've already displayed it. Okay, so let's quickly deactivate and then compare. So that's LandSat 8 and there's LandSat 9. You can see from this high out, there doesn't seem to be any major difference, except you can see that the Sentinel seems to be giving you a much more clearer, much more crisp image. And that's because of the lower resolution. And especially if you look at urban areas. So there's an urban area there, there's an urban area there. So if I LandSat, it's difficult to, from this angle, identify urban areas. But if you look at Sentinel, the Sentinel corresponding, it seems like it's a bit more clearer. Okay. And we do the same for, let's say, for Sentinel, LandSat 9 and Sentinel 2. You can see from this eye up, not much of a difference, except the Sentinel, again, looks a little bit more clearer, a bit more appealing, if you want to, if for lack of a better word. Looks more like a picture. And again, that's because of the resolution. But the real trick comes when we zoom into a specific area. Okay, so let's take this urban area and let's zoom into this specific area. Okay, let's just quickly give it. It will now upload quickly because it's got a smaller region of interest. It should load quicker. Let's make sure it's loaded. Okay, and let's just wait for that one. It's struggling. Okay, here we go. Okay, so let's have a look and see. That's LandSat 8. You can see the urban area is not as clear as a clear as let's say LandSat 9. You can see there. Sorry, Sentinel. There's Sentinel. And you can see the difference. You can see the difference is very evident between LandSat 8 and Sentinel. And if I zoom a little bit more in, maybe into the town itself, and I just look at the two, there's the LandSat 8. Let's quickly just wait for it to load. You see there's LandSat 8, and that's at 30-meter resolution. Okay, remember? This is now an image at 30-meter resolution. Let's load LandSat. You can see this is the image at 10-meter resolution. And you can clearly see the difference in how it displays the image. The 10-meter resolution is much more evident, much more crisp, is much more clearer than the 30-meter resolution. So that's LandSat for the median LandSat 2019 with no clouds. And that's the median LandSat image, no clouds for same period, 2019. Only difference, remember the wavelengths are roughly the same, the scales are roughly the same. So the only difference is the scale. And you can see that ideally, it's going to be better to work with the Sentinel images than the LandSat image purely for this reason. Okay, let's quickly then look at LandSat 9 and Sentinel. Okay, so let's see if the difference is that clear also between LandSat 9 and LandSat and Sentinel, then between LandSat 8 and Sentinel. Okay, so that is LandSat 9. While that's loading, let's quickly see. While it's loading, let me just load the others as well, just to get an idea. Okay, so again, you can see the difference. The LandSat picture, it's almost loaded. There's the LandSat 9. You can definitely see the LandSat 9 being much more clearer than the LandSat. There's LandSat 8, LandSat 9, which is 2023. And if I overlay it with LandSat 2, which is also for 2023, again, you can see the difference that the change in the resolution brings to, and the better it is to present. Okay, so just quickly, just to look at the change, can we detect any change? So that's now the Sentinel image for 2019, and that's the image for 2023. Let's have a look and see if we can see some differences in terms of, you can see there, if this one here, you can see if you look at that, let's move it a little bit. You can see there's some difference there, there's some difference there. Let's have a look. That's Sentinel 9. You can see definitely some subtle differences, but not significant change in the town itself. Here and there, a bit of change in the town, but in general. So here we have another urban area that we're interesting to look at to see whether we can firstly identify that that's an urban area, the feature of the surface, and secondly, whether there's any change in that urban area between 19 and 2023 in that 4-year period. Okay, so just to quickly just refresh, there's our Landsat 8 image for that period. Remember, that's a median image, no cloud cover for that specific area, and it's going to be very difficult to identify that area as having being an urban area from the Landsat 8. Let's have a look at Landsat 9. If it's better, nope, it's not better. So from Landsat 8 and 9, you actually have to be quite far out, meaning from a quite wide, high angle to identify, features, specifically urban features. That's Landsat 8 and Landsat 9. There's 9 and 8. 9 and 8. So not the ideal. Okay, it's very difficult. Again, so now let's have a look at Sentinel and see whether that is making our life a little bit easier. And you can already start seeing that indeed from this position, using the Sentinel image, it's more easier, more evident to identify that specific feature than from the Landsat. So it does appear that identifying features and different features using Sentinel is much better than using Landsat. And again, it is because of the resolution difference. Okay, so let's have a look. So let's have a look at see if we can identify any change occurred in this area. And that is Sentinel 1 and that is Sentinel 2. Let's quickly just wait for Sentinel 2 to upload. It takes a bit of time. Let's have a look and see. Okay, from this top, you can see there's, if you look at this specific area there, that area there, there's nothing there in 2019, and now there's stuff happening there in 2023. So you can definitely see some land cover change or urban expansion occurring there. We can zoom in a little bit. That is Sentinel 1. Let's wait just for Sentinel 2 to load again. You can see there, quite a bit different there. You can see that expansion of houses happening there in that area compared to, you can see this bare soil, vegetation located there. And now with Sentinel 2, we can clearly see a change happening there. Okay, whereas in Landsat 9 and 8, you won't be able to say any much change difference. You can see there, between 8 and 9, nothing much. But between 1 and 2, you can definitely see a change happening there. Okay, so that's just a brief video tutorial on Landsat versus Sentinel, the benefits of using Landsat versus the benefits of using Sentinel and vice versa. So I hope you enjoyed this video tutorial. And thanks for joining me on this remote sensing journey. I trust you're enjoying the journey and looking forward to the next set of video tutorials. And yeah, then I'll see you on the other side.